And we're live! Yay! It's Math 40, elementary algebra. Yay! And we're talking about rational expressions, which is just fancy fractions. And now we're going to multiply and divide them. Woohoo! In order to get started, though, we do need to talk about some vocabulary. And the first bit of vocabulary is the word reciprocal. Reciprocal means basically you're flipping the fraction upside down. So x over y is the reciprocal of y over x and vice versa. Stands to reason, right? Find the reciprocals of these expressions. And then, of course, I gave you the hard ones. Dun, dun, dun. And the idea is that I'm guessing that if I gave you something like 3/4, you know that it would be 4/3, right? These are reciprocals. If they are fractions, turning them upside down is pretty easy. However, the reciprocals when we're talking about variables can be very complicated. The reciprocal of 1 over x is x over 1, which is just x. Anything over 1, you can drop the denominator. If there's a denominator with just a 1 in it, it kind of just falls over. In my mind, I imagine that it's trying to stay up, but then it falls over under the weight. What if it's -1/3? Well, reciprocals keep the same sign. So if it's -1/3, it would be -3 over 1, which is just -3. So far, so good? Now, x plus 8. X plus 8 is like, what? That's not even a fraction. So the hint is write it in fractional form first. So x plus 8 is really x plus 8 over 1. Ooh, you can't see that, so let me scooch up. Sorry about that. X plus 8 equals x plus 8 over 1. And once you write it in fractional form, then you can be like, oh, it's 1 over x plus 8. That's the reciprocal. I'm going to box these guys because boxes always seem more formal and fancy. Okay, so shall we get into multiplication of fractions? So multiplication of fractions, which I'm assuming you've done a little bit of because we have worked with just the numbers before without the variables. Now we've got variables in them, is you perform them by multiplying across the top and across the bottom. So what does that mean? The top, I've got a 1 and a 3, so 1 times 3. The bottom, x times y. So I get 1 times 3 is 3. X times y is, well, x times y. We don't know what they are, so we just write it like that. And we're done. Yay! Multiplication is so much your friend. Okay, multiply across 1 times x. Multiply across the bottoms, x times y. And then we stop and we go, wait. This is something that can reduce. Now we check. There's one term on top, one term on the bottom. As long as there's only one term, you can cancel things. I'm going to cancel these factors. There we go. And then what are we left with up on top? 1 times 1 is 1. On the bottom in the denominator, 1 times y is y. Woohoo! So far, so good? Yay! Okay, so that's multiplication. I know, you're all like, okay, this is making sense. Yeah, just wait. We got a lot to talk about. Now let's do division! Yay! I know you guys are excited. I'm excited. Everyone's excited because we get to divide fractions. Now, division of fractions is the thing that people are usually pretty rusty about. And so I want to remind you that in order to divide, the fact is you can't divide. There is no division. You have to multiply. So the way you multiply is by taking the second. So whoever shows up second ends up getting flipped. So I get 1 over x times, so I change the division to times, and then I write it as y over x. Take a look. This, This is going to be really smeary. I don't want to make it too smeary. Perhaps one of you will go out into the world and invent a smearless highlighter. That would be amazing. Okay, so let's take a look at this. 1 over x divided by x over y equals 1 over x times y over x. So this flipped. That's the reciprocal. Now, one thing that we notice about this is, should you try to cancel things? See those x's right there? Should you cancel across division? No, never cancel with division, because everything is in the wrong place. You have to put everything in the right place. It turns out the x's are right next to each other. You can't cancel them. So if we multiply across the top, 1 times y, down across the bottom, x times x, I get y over x squared. Woohoo. What do you think? Shall we keep going? Yes, let's keep going. Okay, let's keep going. Dun, dun, dun. If I give you a fancy, beautiful fraction, and I want to divide something that doesn't look like a fraction, the very first thing you should do is write it as a fraction. So I've got 2x squared y all over 3y squared divided by, I'm not changing it yet. Oops. This lighting is so bizarre. I keep darkening it and it keeps getting lighter on me. I'm not sure what's up. 4xy all over 1. Do you see that? I took the 4xy and I wrote it in fraction form or fractional form. Now I can change it. The first fraction, the first one to get there, stays the same. I changed the division to a multiplication, and I flipped the second fraction upside down. So far, so good? Okay. So then I've got 2x squared y times 1 and 3y squared times 4xy. Now, a lot of people ask, can I reduce sooner than this? And yeah, there are a lot of times. It just depends on your personal style. I want to make sure I don't reduce before I get to the multiplication stage slide, because I don't want to make a mistake. Okay, let's see what cancels. Anything on top with anything on the bottom, because this is one term. One term. As long as there's only one term, top and bottom, you can reduce anything you want. So y goes with y. Yay. Let's see. I see a 2 with the 4. You see that? And then it is perfectly fine to say, okay, I need to regroup. I need to regroup. Let's see. X squared still on top, right? X squared times 1. And then down the bottom, I've got 3y squared times x. Okay, so this x can cancel with this x squared, and it leaves an x there and a 1 there. And then I think I've got x times 1 all over 3y squared times 1. That's x over 3y squared. Woohoo! Woohoo! That's it. We did the first page. Let's see how far. Well, we're not going to get very far if I can't speak anymore. But let's try some more. Oh, I've always got more problems. 99 problems, and mathematics are all of them. Okay, so those were our sample ones. You guys ready? This is all going to be multiplication. And I lied, because some of it's going to be division, but we'll cross that bridge when we get to it. 1 over x. Oh, I'm doing it in red. Okay, we'll do this one in red just for the heck of it. Times y over x. Or I shouldn't have done it in red. Y over y plus 1. Okay. So I've got, let's see, multiplying across, 1 times y. Multiplying across the bottom, x times y plus 1. So I get y on top, x times y plus 1, or y on top, xy plus x. Now, here's the thing. I personally believe that all denominators should stay factored. because it's very important that you have them factored for the next step. There will be problems where you're going to do something else with it. I would keep it factored. A lot of times other instructors and like WebAssign want you to multiply out. So you should be prepared to either leave it factored if that's what they're asking for, or to multiply out. And just be prepared to do either one. And remember, can this y and this y cancel? No, because there are two terms. Two terms. You can't cancel unless you factor. Now you can factor, but you can factor an x, and the x won't cancel with the y. So you're stuck. Okay, shall we go on to the next one? Woohoo! Start off with this one. 1 over x times x all over y plus 1. See what I did there? It's very similar to the last one, but this time 1 times x, x times y plus 1. Look at that. The x's do cancel because they match. Now you'll notice every time I'm canceling, I'm writing down what's left. If something canceled completely, it leaves a 1. That helps me to remember that if there's nothing left on top, it's basically just 1s. Down the denominator, it's 1 times y plus 1. Woohoo! Shall we do another one? You know it. I'm always here ready with new problems. Now with this one, there's a lot going on. I've got 20y. I've got 6z to the 4th. I've got 9z to the 7th and 5y squared. So you've got some options. One option is you can use all the formulas that I gave you when we were doing the exponent chapter, where you could do z to the 7th minus the 4 if you move the 4. The other possibility, and I mean, this really is up to you, is you can factor everything. So I've got 5 times 4y, 2 times 3z, z, z, z. This is always an option. 3 times 3z, z, 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 5y, y. So if you don't want to use the formulas from the exponent section, you don't have to. You could just cancel individuals. Now this is a lot of work, and there's a lot of opportunities to make mistakes. Let's see, there's a 3 here and a 3 there. I can take 4 z's. 1, 2, 3, 4. And we can see that if we have 7 z's and we can cancel 4 of them, oh, there's a moth. Then we have 3 left. 3 z's right there. Let's see, I've got a y. I've got an extra 3. There's a 4 up here and a 2. Okay, let's see what's left. I think I've got a 4 and a 2. I said 2. You heard me. And my lovely brain, which I've never quite understood what exactly is going on with the wiring. I say 2. My brain says 4. So I think I've got 3 z's left over and a y. And so up on top, I've got 8. Down on the bottom, 3z cubed y. What do you think? Woohoo? Woohoo. Let's see. Is there time to do the next one? I think I'm going to stop it there because we're at 14 minutes. So I will continue. The next video will be more in depth about division. So we'll be doing some division problems, and I keep promising, and we keep not getting to it, we're going to do the conversion of units. Woohoo! Oh, bye-bye, moth. And moth on, or math on. I wonder if it was a math moth.